Hello students, welcome back to my channel once again. In this video, today we are going to learn a very important named reaction from organic chemistry which is called as Reimer Tiemann reaction. What is this Reimer Tiemann reaction, students? It is the reaction in which phenol is treated with chloroform in the presence of a base, for example, sodium hydroxide. So what happens when phenol is reacting with chloroform in the presence of a base? Here you can see an aldehyde, that is CHO group, is introduced in the benzene ring at ortho position. Ortho position means, so phenol, you all know there will be a OH group on benzene ring. So this CHO will be introduced adjacent to the OH group on the benzene ring, and the product being formed is called as ortho-hydroxybenzaldehyde. Okay, and the reaction goes like this, students. This is phenol, as you all know, reacts with chloroform. Chloroform formula CHCl3 in the presence of a base. So I have written here OH minus forming benzaldehyde. OH, CHO, both are adjacent. So this is the ortho position. Hence it is called as ortho-hydroxybenzaldehyde, which is also called as salicylaldehyde. Okay, and there is one more reaction which can also be called as Reimer Tiemann reaction, which is nothing but phenol reacting with, what is CCl4, students? Carbon tetrachloride. Write its name here. So these two reacting in the presence of a base forms, here you can see CHO group is introduced here. COOH group, that is carboxylic group, will be introduced at the ortho position. Hence it is called as ortho-hydroxybenzoic acid, which can also be called as salicylic acid. Now the next step that we are going to learn is the mechanism of this reaction. How salicylaldehyde is being formed when phenol reacts with chloroform in the presence of a base, that is OH minus. Are you all ready, students? Okay, so take your pen, book and be ready. We will learn the mechanism. So mechanism takes place in 3 steps, students. So first step, here in the first step what happens? Chloroform CHCl3, right? 3 chlorine atoms and 1 hydrogen atom in the presence of OH minus. So what happens? This OH minus takes up hydrogen as H plus. So OH minus H plus will be removed as H2O minus H2O. And next, these 2 electrons which are present in between carbon and hydrogen will be shifted towards carbon. Okay. So while writing the arrows, carefully write down, students. See the pair of electrons, 3 chlorine atoms. So one of the chlorine atoms which is present on the carbon atom comes out, taking these 2 electrons present in between carbon and chlorine, comes out as a chloride ion. So here I am writing minus Cl minus. Okay. So what remains? C, 2 chlorine atoms, the pair of electrons, and as this chlorine is coming out, this carbon atom acquires a positive charge, and this is the electrophile, and it is called as dichlorocarbene. This is the electrophile in this reaction. Brackets mention electrophile. Okay, this is the first step. Next, second step. So chloroform's job is done, forming electrophile. Next comes phenol. So phenol converts into phenoxide ion plus H plus. So you all must be knowing how this phenoxide ion is forming from phenol. There is OH, right students? So the bond between oxygen and hydrogen will be shifted towards oxygen. So O converts into O minus. Therefore this is called as phenoxide ion, and H will be coming out as H plus. So this is the second step. Next, third step. The phenoxide ion write it in the third step. So what's happening here? This O minus will be shifted in between carbon and oxygen. So what happens here? A double bond will be formed, and immediately these pi electrons will be shifted towards this carbon. Hence this carbon acquires a negative charge. So next structure, double bond O, and this carbon acquires negative charge. Okay, so here comes the electrophile which is formed in the first step. What is that electrophile? Dichlorocarbene. So write down here students, C, Cl, Cl, the pair of electrons and the positive charge. So there is minus here, positive here. So this minus attracts a positive charge. So write the arrow like this. This carbon with negative charge attracts this carbon with a positive charge. So by this, the two bonds inside the ring, here double bond O. Now this carbon gets attached to this carbon, C, Cl, Cl, the pair of electrons. So students, here we need the carbon present on this hydrogen present on this carbon. So I am showing it here. We all know there will be a hydrogen here, 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 here and here. So this hydrogen, write it outside. Okay. Now the pair of electrons present on the carbon takes up this hydrogen. So hydrogen is coming out as H plus. Don't touch the bond over here while writing the arrow. Fine. So H is coming out as H plus taken up by this carbon with a pair of electrons. So a bond will be formed between hydrogen and carbon. Now these two electrons will be shifted inside the ring. Okay. And the pi electrons will be shifted towards oxygen. Okay. Next. Write an arrow over here. Try to write the next structure. Two bonds which are already there. Now one more bond coming inside. Here single bond O. So these two electrons shifted towards oxygen. Hence it gets minus. here C, Cl, Cl. Now hydrogen CHCl, Cl. Okay, clear? Next, here comes, here it takes up two molecules of NaOH. Write down here. Two NaOH. Now can you guess what happens when it takes up two molecules of NaOH, students? The previous structure is this one. Okay, can you guess what happens here? There are two chlorine atoms, right? So 2 Na and 2 Cl will come out as minus 2 NaCl, and the 2 OH minus ions will be coming over here. Here 1 OH and here 1 OH. Come on, let's write the next structure. Here below write down minus 2 NaCl. All the three bonds inside here, O minus, carbon, H, and in the place of OH, Cl, we'll write here OH, OH. Okay, so two OH groups on one carbon atom is unstable, and hence it comes out as water molecule. What comes out as water molecule? One hydrogen and oxygen, and one this OH group comes out as H2O. So write down here below the arrow minus H2O. So finally what remains? O minus, C, here there is hydrogen. Now once this water molecule comes out, this oxygen and these two bonds, it converts as a C double bond O. This is the aldehyde group, students, CHO. Now the last step, addition of H plus. Okay, now this O minus takes up H plus, forming OH. So are we not getting the product which is written in the reaction, students? This is salicylaldehyde. OH, CH. So this is the complete mechanism of Reimer Tiemann reaction, students. The mechanism takes place in 3 steps. I have given very clearly all the 3 steps. Please don't try to practice, don't forget to practice twice or thrice. Then only you will be able to write it without seeing, which is very, very important for your examination. Hope you understood. Hope I made it clear, students. So those who are watching for the first time, please don't forget to subscribe the channel, like it, and also share it with your friends. So meet you in the next video, students. Until then, take care. Bye bye.